So our vision is we are a generational enterprise, and we bring success to our customers, stakeholders, and employees. Very simple mission. We promote excellence by cultivating high-performance employees using innovative processes and creative technologies that bring value to our customers. So as a BPO, we typically do back office work. So we are not typically associated with call center work. So it can be a relatively confusing story of what we do. So I'm going to try and highlight the story that is us. So we started out as first American Data Exchange. So some know it as ADEC. And basically, if you look at real estate transactions in the US, we process more than 50% of all the real estate transactions in the US. And that's in partnership with First American, who are our partners with this BPO process. So we started this journey about 18 years ago, and I think today we process somewhere between 50 and 40 million transactions a month for that particular business. And then we got a lot of our customers turn around and said, well, we love the work you do for us here, but we have issues whereby we must keep our transactions onshore. So that instigated us doing onshore BPO. So we have centers in the US, the UK, and Australia. And at some point in time, and for a lot of us who work at ADEC, and for those of you who know our CEO, he decided that we needed to get into the sustainability business. How do you equate sustainability with BPO? Well, we're looking at it from a data perspective. So the first thing we did is we brought a major company in the US, and if you look at the types of things we do with sustainability, an example project would be Hollywood Central Park. And a lot of people say, well, we know that there's another Central Park. We didn't know there's a Central Park in Hollywood. Well, if you look at the parks in that area, they are very disparate and they're not joined. So if you go to one park, you can't go to the other park because there's highways in between. So we're the guys that are doing the environmental work to figure out how we cover up all the highways and to make one large central Hollywood Central Park. So that's the type of environmental work we do around the world. We then had a vision whereby we have a lot of call center people, well, a lot of back office BPO people who can't necessarily afford to educate their children in the same way that probably most of the people in this room could. And our founders decided one day that they were going to buy a school. And that school's A+, which some of you would have seen it in Festival Mall. And we decided to subsidize our staff to allow them to send their kids to our school. And from that beginning, we ended up getting into e-learning. And next thing we know, we're doing Chinese teaching. And we teach Japanese, and we teach English to Chinese. And before you know it, we have hundreds of people in China and hundreds of people here training and doing e-learning. And then we decided that, well, we might as well keep going at the same theme, and all of a sudden we are doing e-learning. So we're converting material that is paper-based into electronic learning systems. So the next thing we know, we decided that it would be a good idea to buy a university because we are a BPO, so why not buy a university? And it might be a good idea to actually stick the BPO right next to the university. So we brought the university in Salai and we built a BPO operation there. So that's BPO Asia. Pharma KPO is a joint venture between ourselves and Zulig Pharmaceutical and the Singapore government. So that's primarily focusing on knowledge-based outsourcing. So things like clinical trials and related data. About 18 months ago, we decided to look at environmental data. And we decided to get a company called Envirosight off the ground. And the story today is very much focused on a dream that we had. We didn't realize how naive we were going to be with this particular dream, but this is a story about that dream. So I'm going to assume that some of you in this room are not technical. So big data can be characterized as the amount of digital data that is uncomfortable to store, transport, or analyze. Big data for dummies. Yep. So big data can be characterized using the 4 V's. So most of you have probably heard of this, but for those who haven't, here we go. So volume, or the scale of the data. Right? It's this huge amounts of data that are coming at us all the time. Now somebody said, well, how do you put that into context so that everyone understands? Well, by 2020, the size of the data is 57 times more than every grain of sand on every beach in the world. The next thing we're dealing with is the variety of data. It's coming from all sorts of sources, and we'll go into that in a little bit. One of the things that will shock a lot of people is the amount of money that's wasted. And if we look at IT in particular, the analysis done by many of the consulting firms basically comes to the conclusion that at least 50% of all the money we spend on software development goes to fixing bugs, which means we basically have a world of buggy software and bad data, to the extent where it costs the US economy about $3.1 trillion a year. Healthcare alone, 14% of healthcare costs in the US are because of bad data. It's a huge problem around the world. And obviously the velocity of data, it's coming from all sorts of directions, and I'll go into that in a minute. So the amount generated on the planet is growing exponentially. Well, we've already heard that today, and as we said, it's growing by 50 times by 2020. And just for reference, if anybody wants to know what a zettabyte is, that's basically it down there. It's a lot of zeros. So we talk about the cloud, but from an average user, what we don't realize is the cloud basically signifies that we use 16,000 acres of physical land where our data centers are. Right? So to put that into perspective, that's the equivalent of a 2-lane highway from Tokyo to San Francisco. So what fuels big data? It's a lot of things. We talked about a lot of these today. Social networks, agricultural, medicine, healthcare, security, everyday Internet of Things, satellites, phones. So some say that the Internet of Things is the third revolutionary and mass internet connectivity. It is currently where the World Wide Web was in 1994. And it's growing with expected 26 billion units by 2020. And when we look at devices, that doesn't include our PCs, our phones, our tablets, our computers. It's just devices. And as we also heard today, the fact that that's already been replaced by the Internet of Everything, which will be the next wave. Now, as a company, we manage supply chains, in particular with companies like Nike, where these companies are very, very concerned about child labor. They're concerned about working conditions in factories in Pakistan and China. But they're also concerned of the cost of doing audits. So going to a factory and doing constant audits on these factories becomes very, very expensive. So one of the things that we are using the Internet of Things with is to put devices inside the factories. So one of the questions that comes up is, how much of this data do we actually analyze? Does anybody know? Anybody would say that we analyze 10% of all this data? Because we've all heard that 80% of the world's data was created in the last 2 years. Would anybody put their hands up to say we analyze 10% of it? Well, that's how much of all this data we analyze. So if anyone is looking for the next big industry in the Philippines, we should be looking here. So we went through a phase where we analyzed data typically from our ERP systems, from our internal systems, all the things that were in close proximity to us. And then this animal called big data came along, and nobody really knew what to do with it. And we're starting to see a convergence now, and they call it Analytics 3.0, but it's a convergence where we're actually starting to analyze some of this data. So who are the pioneers? Well, we've all seen the pioneers being Google, Amazon, eBay, Facebook, LinkedIn. There are a number of pioneers in this industry. And as somebody who's obviously stole some of my slides, we have people like GE who have initiatives called the Things of Spin, where GE are spending $2 billion in analytics. And as we already talked about today, they collect more data, or 7 times more data per day than Twitter does. So one of the things that would surprise people is we have always been into data. So each one of our companies generates a lot of data. As I said before, First America does somewhere between 40 and 50 million transactions a month. Well, that was till we added EnviroSight. And that 40 or 50 million transactions a month, at some periods, hits 6 billion transactions a month. That's with a B. So where do we get this data from? So we actually collect data from 1,507 environmental sources around the US. So that's federal data, aerial photography, soil, erosion, hazards, nuclear, radon, soil, fires. It's only a few of them. We collect 1,507 databases. So what do we do when we get all that data? Well, oops. Unfortunately, we have to extract that data, and we get it in PDFs, we get it in CSV, Excel, we have to scan some of it, we have to screen scrape some of it. Some of it comes in database formats, some of it comes in just pieces of paper. We have to transform that, so we have a team of about 75 data analysts that have to actually manipulate and get that data into some format that we can use. We obviously have to use technologies, in particular technologies like Talent and ETL type tools to translate that data. We then have to put it somewhere. So some of the data is stored in what we call relational databases, but a lot of it is stored in Hadoop, which is a MapReduce file system or a NoSQL database. Obviously all this data, because we're dealing with federal data, government data, if we produce a report from this data and it's wrong, we can get sued. So we have a huge QA component to that data. We then take all these data sources, and at the end of the day, we extract physical addresses from those sources. So we build up a database of physical addresses that we then reference with our technology. So we have to then take those addresses and geocode those addresses, and we'll talk about why that is. And then at the end of the day, we have to deliver that data to us. And we use a couple of technologies. One is traditional database, delivers some of the data. And if anyone's ever used Facebook, you'll notice that the first page comes up really quickly. That comes out of a relational database called Oracle. When you go to your second page and you scroll down, you'll notice it's just a little bit slower than that first page. So the second page is coming from actually Hadoop. So we deliver that with a product called Solar and Lucene. So for those who don't understand what that is, if you've ever done a search on LinkedIn or Facebook or Twitter or any of those products, they all use these technologies. They're all open source technologies. And at the end of the day, we consume that data in a product that's going to make us money at the end of the day. So, what technologies do we use? As I said, we use Solar, we use ArcGIS, which is a product from Esri. A lot of people have said to me, why don't you use Google Maps? Well, when you have your Tomahawk missile go somewhere and land somewhere, that's using Esri software. It's not using Google Maps. All right? So Esri gives us far more than our typical street maps. All right? We use a product called OutSystems, which is a platform as a service development environment. We use Hadoop. We use a product called Node.js. We use Lucene, HTML, all those other nice things. At the moment, all of this is hosted on Amazon Web Services, and we've been known to spend in excess of $70,000 a month on Amazon. So for those technical people in the audience, just very briefly, we utilize a product called Node.js, as it allowed us to get about Esri as a service that delivers maps is quite an expensive service, and you typically can get 70 concurrent users on that service before you have to buy another Esri box. By using Node technology, we were able to scale that to 300 users. So Philippine innovation to save money, but to also give us good value for the money we are spending. We have banks of servers as far as web front-end servers and Hadoop cluster, etc. So let's talk about big data by the numbers. So we have over 30 technology and business professionals, some of them who are in this room, who pretty much dedicated their life to collecting environmental data over the last 2 years. We have about 75 data analysts who work 24/7 processing this data. And it's been a 2-year mission for all these folks. And our goal is to redefine how environmental data is delivered. Now, to us, the environment is something that's very, very sacred. And when you have the opportunity to talk to some of our scientists, the tipping point for our planet, according to them, was 7 years ago. So there is no going back. They are saying now, and there's an interesting thing that if anyone links to me on LinkedIn, you'll see the article that it was posted today, is that some of the biggest names in finance have got together, and they've now produced a report which is showing the potential economic impact on the US from environmental issues. The report is so significant that it clearly shows that people who live in places like Miami and Florida in the coming years are not going to be able to get insurance for their homes. The economic impact of the environmental changes are going to be more than the financial crisis we've had. So if we think this is something we don't all have to live with, think again. It is. So, As I said, we process 1,507 database sources, and pretty much every single one of those sources we get is bigger than 64 gigabytes. Some of the files we process contain 1 billion attributes, and we have to do that 50 times for every state. You're talking massive amounts of data. We have over 45 map layers. You're talking over 70 terabytes of maps. And we are seeing data throughput as much as 10 megabytes of data per second that we're having to process. So, what did we actually produce with all this big data? So this is one of our main sites. So this is a site that will allow you to do a stage 1 property evaluation in the US. So basically it's your environmental report that you get when you buy a property. So it's the report you have to take to the bank. There aren't a lot of competitors in the US simply because nobody can afford to deal with this much data. The cost of getting into this particular business is extremely high. So here's an example of a property. It's just a small property. It's called the White House. And you can see that showing that particular property. It's got surrounding areas of concern around it. And it's showing that property with the flood zone map overlaid. Here's the same property, and it's showing that property with the federal lands overlaid onto it. And now you're seeing the same property with an historical map from nearly 100 years ago. Right? So it gives you the idea of the types of things that you can do with this application. Now, how significant is this? Well, if you get the report from our competitor, who doesn't know we exist yet, we'll do in the next coming days. If you get this report from our competitor, you have to do it manually. And once you ask for the report and you specify what you need, you will get the report via PDF in 2, maybe 3 days, if you're lucky. If you have a major project that they need physical copies of this, like major project as an example, what happened with the Trade Center, you would literally have a semi-truck deliver some of these reports. This product that was built, the idea was created here, and this product was built in the Philippines by Philippine developers. You will be able to get your Phase 1 environmental report online. And the minute you define all the parameters that you need for that Phase 1 report, you will be able to produce the report online. So you'll no longer have to wait days for a report to be delivered to you via email. So what other things do we do? So, taking aside the commercial use of this data, we then decided to think about what the consumer could do with this data. So imagine taking your phone and walking over to a property, as we're seeing here, and being able to get information about that property. Right? Imagine being able to take your phone down the bottom of BF and knowing instantly that that property you're looking at floods 6 times a year. And this is also using a technology called Augmented Reality. So that's not a picture of the guy's holding the phone up in front of the property. So this is telling me that this property is getting a 75 out of 100 environmental score. So this property I'm looking at now has got a 75 out of 100. And the next question is obviously why? Well, the particular property is okay, but there's something in the surrounding area, and typically we do a 1 mile radius from the property, there's something in the surrounding area that is hazardous or poisonous or radiation, or there's been a meth lab. There's something in that surrounding area. And at that point in time, they have to send a message to us and pay $29.99 to get more details. But it allows you to actually understand some of the things that are going on in the surrounding property. It gives you information about the property. Most of this is public information. It'll also give you information about the particular town or city you're in. We also write solutions for, obviously, the environment, so sustainability, so managing water, power, waste, carbon emissions. So we have various products that allow our customers to manage those sustainability projects that occur within their organizations. And here we're seeing what we talked about, the actual feeds that are coming in from a factory. So temperature, humidity, noise, so on and so forth. Most of the factories that we have these devices in, we also have cameras, so we can get live feeds from the factory. And there's a lot of information that is voluntarily put in by the factories themselves. So information about the age of the people working, timesheet information, etc. We use all this data to actually analyze whether the factory is telling us the truth. So we do comparisons between factories in the area. We look at the types of data they're sending us and any likelihood that there's any fraudulent activity going on with that data. And obviously all these products we produce are all what we call responsive web design. So we don't produce a product for this and a product for a tablet and a product for a website. All our products are designed to work on all of the devices. All right? Once again, all our staff and all our development is done in the Philippines for all our countries. So, if anybody's thinking of getting into big data, I was going to say think again, but understand the data and how to process it before you venture into big data. We lost many, many months of valuable effort because we really didn't spend enough time understanding how complex some of the data was we were dealing with. Be prepared to invest in a large learning curve with big data. My recommendation would be is don't try to reinvent the wheel. There are a lot of companies out there that have packaged a lot of these open source technologies. One of the ones you probably heard about is a company called Cloudera, who basically took the big data technologies and they packaged them up. Sounds like a simple idea. It's obviously a good idea because Intel invested $500 million in them, and they don't own a product. Spend time understanding the best NoSQL technologies. And by the way, NoSQL stands for not only SQL, right? They still do exactly the same as our traditional relational databases do. But understand the type of technology you're going to use because they're all different. There's a technology that everybody has probably heard about called MongoDB and CouchDB. And everyone's going, these are NoSQL databases. They're so innovative. They're so wonderful. Does anybody realize that the same guy who built Lotus is the same guy behind that technology? It's not new technology, it's just becoming, I guess, more popular. Big data is a very expensive journey, believe me. Our CFO has almost been on her knees crying at times. It's very, very expensive. And last, when you're about to give up, you may be closer than you think. Thank you.